Next comes potential due to a ring of charge. Okay, now we have a ring of charge. So here's my ring, okay? It's a hollow ring. And I have to find potential at point P. The easiest scenario would probably be at the top, okay? Again, what do I know? I know absolutely V will be given by K dq over R integration, right? I also know that if the ring is this shaped, I can take a segment of that ring and I can call it dq, to have charge dq. If I have this segment, I can calculate that, I can call this one R, and I can call this direction Z, then this direction will be Y, and this direction will be X. In fact, I can make my life a little bit easier if I use cylindrical coordinates. Okay, so cylindrical coordinates will be R theta Z. Okay, that means if I have this volume element, instead of talking about the dl or dz as we were talking about, in this case I am going to talk about ds, which is the segment, and I know ds is rd theta, or rd phi, however you'd want to call it. Okay, so this is my volume, this is my element, which has a charge dq, and since this is z-axis, I can call this as r. Okay, what else do I know? Oh, I know dq will be lambda ds. Okay, so that means I can plug this value in here. This will be lambda r d theta. Good. Okay, what else? I know r, big R, looking at the picture. Oh no, little r. Let's talk about little r. So this r will actually be equals to r squared plus z squared. R squared plus z squared square root. That should be all I need. So now next step will be to plug all of these equations in. So this goes in here, this goes in here. What do I get? V will actually equals K lambda r d theta divided by r squared plus z squared. Square root. Don't forget the square root. Okay, now our integration right now appears only over d theta, which I know if I'm integrating over d theta goes around, goes from 0 to 2 pi. That means it's k lambda r over r squared plus z squared square root, comes common out. Integrating over d theta from 0 to pi basically results in k lambda r 2 pi divided by square root of r squared plus z squared gives me v. Excellent. Now let's talk about limiting cases, right? In limiting cases, what will happen? Limiting case would be when z becomes very, very large. When z becomes very, very large, that means v, if z becomes really, really large as compared to r, I can ignore r in this expression. So what will I be given? I will be left with k lambda r 2 pi divided by z. Or k 2 pi r is the circumference. So this will be equals to, this whole expression here is actually equals to 2 pi r d theta r lambda is actually equals to q, the total q, q over z. So what does this say? This basically says is that if you are far away from any distribution, it basically appears like a point charge. It behaves like a point charge.